Good morning, student. Myself Jyotirmoy SAHOO. I am the lecturer of Electronics and Telecommunication Engineering branch. So, today we are discussing about the chapter 2 of Microprocessor and Microcontroller, that is instruction set and assembly language programming. So, first we will discuss about the addressing data and differentiate between 1 byte, 2 byte, 3 byte instruction with examples. So, the word size of 8085 instruction can be 1 byte instruction, that is, for example, RB. The code and operand are in the same byte. Then 2 byte instruction is MVI A,05H. The first byte specifies the code and the second byte specifies the operand. 3 byte instruction is LDA 2000H. So here the first byte specifies a code and the following 2 bytes specify 16-bit address. So this is different type of, that is 1 byte, 2 byte and 3 byte instruction. Next is addressing modes in instructions with suitable example. So the various techniques to specify the data for instruction is called the addressing mode, in which we have to specify the data or the information. So there are 5 types of addressing modes are there: direct addressing mode, register addressing mode, register indirect addressing mode, immediate addressing mode, and implicit addressing mode. So direct addressing mode is the address of the data is specified in the instruction itself. For example, STA 2000H, IN07H. Next is register addressing mode. The operands are in general purpose register, for example, move A, B, add B. So, the data or the operand is present in the general purpose register in register addressing mode. Next is register indirect addressing mode. So, the address of the operand is specified by the register pair indirectly, for example, move A, M and add M. Next, immediate addressing mode. The operand is specified within the instruction itself. For example, MVI A,03H, ADI 12H. So, here the operand or data is specified within the instruction. Next is implicit addressing mode. The operand is in the accumulator, that is CMA means complement the content of accumulator. RAL means rotate the accumulator left. Next, RAR, that means rotate the accumulator right. That means here the operand is present in the accumulator in implicit addressing mode. So these are the various types of addressing mode in 8085 microprocessor. Next is instruction set of 8085 microprocessor. The entire group of instruction is called the instruction set, and this determines the functionalities the microprocessor can perform. The 8085 instructions can be classified into 5 functional categories. For example, data transfer operations, arithmetic operations, logical operations, branching operations, and machine control operations. So first we will discuss about the data transfer instruction. This group of instruction copy the data from a location called a source to another location called a destination without modifying the contents of the source. The various type of data transfer are between registers, for example, move B, D, that means move the content of D register into the B register. Here the data is transferred between two registers, B and D. Next is data byte to register or memory. For example, MVI A, 45H, that means move the 8-bit data 45H into the accumulator. Next example is MBI M,34H. Here the 8-bit data 34H is moved to the memory. Next, between memory and register. For example, LDA 2100H. LDA 2100H means load the 2100 data, means 16-bit data, into accumulator. Next is between input output device and accumulator. So for example, IN16H and OUT means out 12H. So in 16H and out 12H are the example of input, means data transfer between input output device and accumulator. So this is all about the data transfer instruction. Next is arithmetic instruction. The arithmetic instructions are addition, subtraction, increment and decrement. So addition means any 8-bit number or the content of a register or the content of a memory location can be added to the content of accumulator. The sum is stored in the accumulator. The DAD instruction adds 16-bit numbers in register pairs. For example, ADDR means add the content of register with accumulator. ADCR means add the content of register with the content of accumulator and also with carry. Next, ADI 8-bit, that means add the 8-bit data with the content of accumulator immediately. Next, SCI 8-bit means add immediate this 8-bit data to the content of accumulator with carry. Next is subtraction. Any 8-bit number or the content of a register or the content of a memory location can be subtracted from the content of accumulator. The result is stored in the accumulator. The subtraction is performed in 2s complement form. For example, SUI 8-bit, that means subtract immediate the 8-bit data from the content of accumulator. Next, SBI 8-bit, that means subtract the 8-bit data from the accumulator. SUBR means subtract the content of register from the content of accumulator. Then SBBR means subtract the content of register from the content of accumulator with borrow. Next, logical instruction. These instructions perform logical operation with the content of accumulator. These instructions are AND, OR, XOR, rotate, compare and complement. For example, ANI 8-bit, that means AND the 8-bit data with the content of accumulator. Then XRI 8-bit, that means XOR the 8-bit data with the content of accumulator immediately. Next, ORI 8-bit means OR the 8-bit data with the content of accumulator immediately. Next, logical AND. Any 8-bit number or the content of a register or the content of a memory location can be logically ANDed with the content of accumulator. The result is stored in the accumulator. So next instruction is branching instruction. This instruction alters the sequence of program execution either conditionally or unconditionally. These instructions are jump, call, return and restart. For example, JMP 16-bit, JC 16-bit, JC means jump with carry. JNC 16-bit means jump with no carry. Next, JZ 16-bit means jump with 0. JNZ 16-bit means jump with no 0. Next, call 16-bit and RET. RET means return instruction. Next, machine control operation. These instructions are halt, interrupt and do nothing etc. For example, NOP, HLT, DI, EI, RIM and SIM. So NOP stands for no operation. HLT stands for halt the microprocessor, that means to stop the microprocessor. Next, DI means disable the interrupts. EI means enable the interrupts. Next, RIM stands for read interrupt mask and SIM stands for set interrupt mask. That's all. Thank you.